Okay, so now we're going to start off with our 20-minute short questions on Coca Cola. Now, tomorrow at your play scheme, you're doing some experiments with Coca Cola, so we thought it would be interesting to learn about Coke and what it actually means. So, what sort of different types of experiments can we have with Cokes? Well, the first one is to do with a can of Diet Coke and a Coke. So today we're going to look about experiments with C-O-K. Yeah, with Coke. So the experiment one is to do with having two cans, one of Coke, one of Diet Coke. Okay, one with just Coke and one of Diet Coke. Now, which one of those, if you put them in water, or do you think those cans would sink or float if you put them in water? Do you think they would sink or do you think they would float? What do you think they'd do? Sink or float? Sink. I would too. Do you know what actually happens when you put those cans of Coke in? The Coke actually sinks, but the Diet Coke floats. So if you did an experiment with a can of Coke and a can of Diet Coke, which one would float? D-I-E, D-I-E, Diet. Okay, we're doing really well, really well. Come on, pointing's great. C, O, K. Yeah, the Diet Coke would float, and the actual can of Coke would S-I-N. Okay, yeah, it would absolutely sink. So why is that? Why is it that if you held them, you think they were the same weight? Why is it that one floats and one sinks? Well, that's all to do with something called density, which is about mass. So the reason one sinks and one floats is because it's to do with D, E, N, S, I, D-E-N, S-I, T, Y. That's right, and density is to do with not weight, but M. Okay, you're doing wonderful. M, A, S, yeah, to do with the mass. So from learning about that a can of Coke sinks but a can of Diet Coke floats, from that we must deduce that Coke is denser than Diet Coke. So what is a low density? Low density is where things are spread out more. The mass is over a larger area, like a sponge, and high density is where they're packed together closely, like a rock, so they're more close together. So an example of a low density item would be S P O S P O N G E. That's right, because the mass is over a larger area, whereas a rock, it's packed together more. T I G H T T. Keep going, doing great. L Y. Brilliant. Okay. In the case of the Coke and the Diet Coke, the reason that the Coke sinks is because sugar is actually more dense than the sweeteners that they use in Diet Coke. So the reason that the Coke sinks is because the sugars are D keep going, D E N D E N.
Mum.
Yeah, Mum out at the moment having her hair done, and then we'll see her when we've finished. S E R. The sugar is denser than the stuff that's in Diet Coke, which is the S W in the John E T and then S W E T T E. Keep going, doing brilliant. Keep the flow. N E R S. Great, yeah. So sugar is denser than the sweeteners, which is why one floats and one sinks. Now about another experiment. They actually use Coke to clean coins, dirty coins, and they put it in Coke, leave it for a while, then rub it off, and then you can clean up a coin. So another experiment with Coke is actually cleaning C O I. I know you want the N S. Yeah, cleaning coins. So how does that actually work? Why does Coca-Cola clean coins? Well, what they believe is that an acid is formed by forcing the carbon dioxide in the Coke into a liquid form. This releases bubbles, which then creates a carbonic acid. So one of the ways that they think it works is that an acid is formed by forcing the C A R B C A R B. Keep going. O. Yeah, you're there. Go for your N. N. Carbon. D. I. O. D. I. O. D. I. O. X. I. X. I. D. E. I know you're there. But forcing carbon dioxide into its natural state, which is a L I Q L I Q U U I. Finish your word. Brilliant. Yeah, into its liquid form. This then releases bubbles and forms a acid that's called A C A R well done. B C A R B O C A R B O. Keep going, finish your word. N. Keep going. Up to your I. Keep the flow. I. Carbonic acid. Fantastic. Now this carbonic acid is a kind of mild cleaning agent, but actually what it does is strip the top layer of the coins, which is why it makes it clean. So the carbonic acid is a mild cleaning agent, but it really just strips the T O P, the top. Great job, keep going. L A, can you sit down? L A Y E. Oh yeah, it just cleans, yeah, it strips the top layer. Okay. Now, did you know also, sit back down, you're doing great, that blood, they use, Coca Cola is used by the police in America to clean blood off the pavements, and they also use it to get rust off steel. So another use for Coke is for B going B L O O D to get in blood. O F F off, blood off. Okay. Well done, you're doing really well. P A V B A V, fantastic. Keep going. Oh, sorry. Knocked it out your hand. P, sorry. P A V E M E P A V E M E N T S. Right, yeah, cleaning blue off the pavement. Doesn't sound very healthy, does it? Okay. Now what about another experiment? Quickly, and one more. You need to take a moment. You can have a look. You want to check if mum's in? So another experiment, amazingly, did you know that you can make a rocket out of a bottle of Coke, and you can make it erupt up to 10 metres high? So another experiment that you can do with Coke is to turn a bottle of Coke into a R O R O. That's it. R O. That's it. R O C K C K E E keep going. E. Yeah, a rocket. And you can actually make it erupt. How many metres high can you make it erupt? 1. Yeah, 10 metres high. Now, bizarrely, the way you do this is to use sweets called MENTOS, MENTOS, and that's what you do. You drop the MENTOS into the bottle of Coke, and the rough surface of the MENTOS, the sweet, creates a bubble growth site. So the sweets that you'd use to do this are called keep going, doing really well. MEN yeah, you're there. Go for your T. T. Keep going. Finish your word. You there? O. Hey, they're called Mentos. Yeah, Mentos sweets. And one of the reasons this is good for Mentos sweets is because they have a rough SU. Keep going, doing really well. SUR. F. Up. You're doing really well. Finish your word. Up to the A. Come on. Keep it going. Doing really well. SURF. A. C. AC. Finish off. Go for your E. E. That's good. Has a rough surface, and this creates something called a. No, you want the B. Go. That's it. B. I know you were getting there. B. U. B. U. B. U. Go back. You're there. Look. You're up. B. 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 L. E. Lovely pointing. A bubble. G. R. G. R. O. W. T. G. R. O. W. T. H. A bubble growth. Well done, this is fantastic. A bubble growth. S. I. T. E. A bubble growth site. I do. Now, one of the ways it's linked to a bubble growth site is by something called low surface tension, which the surface of the Mentos helps to create, and also because the Mentos are dense, they sink very fast, which creates more bubbles as well. So what's one of the ways that the Mentos creates bubbles? S. I. S. I. N. S. I. N. K. S. Sinks. I know you want your F. Go for your F again. Up. F. Lovely. F. A. That's it. S. So yeah, it sinks fast, and that's another reason that it creates the bubbles. Now, the low surface tension is actually better in a Diet Coke rather than Coke, which is why Diet Coke works better. So Diet Coke works better because it has a low surface T, E, N, N, S, up, T, E, N, S, keep up, you're there, I, O, fantastic. Okay. Now, so that's 3 experiments we've done. We've done the cans, the density of the cans, the cleaning coins, and the rocket. And you might do some others at play skiing tomorrow, but you'll know a little bit about the science of Coca Cola. So what about some general facts? Well, if you had to try a new product every day that Coke makes, and you want to try all of their products, it would take you 9 years. 9 years for you to try all of their products. So if you wanted to try a product today, it would take you how many years to try them all? 9. So if we wanted to work out how many products they own, the sum would be 9 times 3, 6, 365. Yeah, 365. So can you do that in your head? Okay, so 9 times 365